Welcome to the AMATIC 2015 webinar series, Activities for Hybrid or Flipped Classes with Julie Gunkelman. And this presentation is sponsored by the Innovative Teaching and Learning Committee of AMATIC. AMATIC is the American Mathematical Association of Two-Year Colleges, and our core value is building expertise and exhibiting leadership in the teaching and learning of mathematics, enhancing personal growth, and improving teaching methods and effectiveness as a personally initiated lifelong responsibility. And for more information, please visit our website at amatic.org. And please note that the views expressed by the presenter are not necessarily the views of AMATIC, and any commercial products mentioned by presenters are not endorsed by AMATIC. And the AMATIC series this year is proudly supported by WebAssign. And so now we're going to actually switch to Julie's slides, and that is going to be on her computer. So if there's a delay, I apologize. And now I think I'm going to just, okay, there you go, Julie. So I'm going to turn it over to Julie. So if you could all welcome her in the chat room, that would be great.
Thank you. Just get this to be full screen here. There we go. So I'm Julie Gunkelman. I am from Michigan. I'm getting over a little bit of a cold, so I probably don't sound as normal as I normally do. I appreciated seeing all the places that you guys are from and what you already teach. But before I get going with my presentation today, I have a question for you, and it is, do you currently teach a hybrid or flipped class? And John is going to let you answer that question with one of those polls that he mentioned right here in the beginning. So the choice A is going to be that I do already teach a hybrid or flipped class. I plan on teaching a hybrid or flipped class within the next academic year, or I'm just considering it. So here's the poll, and go ahead and log your choice in. Okay, so it looks like I'm trying to do a quick count here. It looks like everybody has participated, and it looks like it's about, I don't want to say a third, because I'm obviously just talking to a bunch of math majors, but it's kind of even. So it's, some people are already doing it, some people are thinking about doing it, and some people have already planned on doing it. That's awesome. So if something comes up along the way, please enter it in the window if you already do something that I'm talking about. Or you have another idea that you could share with somebody, that would be awesome to do. Before I start and actually talk about the activities, though, I wanted to actually define what I mean by hybrid classes and flipped classes. So I teach a couple of hybrid classes, and they meet half the time as a traditional face-to-face class. So if this was a 4-credit-hour class that I'm talking about, we're talking about meeting 2 hours per week instead of the 4 hours per week. What I have done with all of my hybrid classes is all of my notes are posted online. I call them video notes. So they're videos that I have made and post online. And per my department requirements here at OCC, all of my assessments are taken in class. I don't have a testing center that I could utilize or any online testing kind of situation with these classes. So very similar, when you see the description, are my flipped classes, and flipped classes are going to meet the full time, just like a normal face-to-face class is going to meet. So a 4-credit class would meet 2 hours twice a week. I generally don't teach in 4-hour blocks, although the college does offer some of those. Again, all of my video notes are posted online, so all the introductory material that I have for my class are posted online. And again, of course, all assessments are taken in class. So usually the question that I get when I describe the situation is, people say, what is it that you do in class? And so that's what I want to focus on today. And there's 4 things that I grouped them into categories of basically what it is that I do in class. So one of them is to practice. Another thing I do in class with my students is to connect and extend those topics that we're talking about. I review, and I also motivate. So I'd like to take each of those four things this afternoon and go through them and give you a couple of examples of things that I actually use in my classes. When you guys were logging in and chatting, I pretty much picked up that the classes that you teach are from pre-algebra kind of all the way up through, I think I saw Calc 3. I might have seen differential equations, linear algebra, that sort of thing. So my examples range for this webinar today. I probably close to that range. It's going to be close. I do have a couple examples from Calc because I'm teaching that right now. So that was what was foremost on my mind. So the first thing I want to talk about is practice. And when I am in class, one of the things I like to do, I like to get the students involved. And so sometimes I do activities like this, that is this hexagon puzzle. Susan Walls actually came up with it. And something I did find on the internet. And this class was a college algebra class. And students had these triangular pieces. And there's like different expressions on them. There are some equations. I'm going to show you a better picture of it in a second. And they will work them out to try to make what's equivalent on each of the sides so that they can match them up. So when it gets all put together, it does form a hexagon, and it looks something like this. So here's my hexagon puzzle. So a couple of things I wanted to point out. Here is an equation, right, that they would solve and they would match up so they can get that particular value for x. Some of them are, they're the equivalent expressions for those complex numbers. And then there are also, these are kind of strange at first when students see them, but they are actually conjugates. So the Susan has got the asterisk on there to say, hey, this is going to be a little bit different. It's not going to be equivalent to the same as what's in the rest of this puzzle, but actually instead they are indeed conjugates. And so this activity has been very useful in my college algebra class to review some of these things and talk about how things are same, different, etc. At one of our Mishmatic, which is the AMATIC affiliate in Michigan, at one of those Mishmatic conferences a couple years ago, I met a gentleman, and unfortunately I don't know his name to give him credit today, but he had come in and done one of the workshops during our Mishmatic conference, and he had all kinds of expressions with algebraic expressions like this with exponents written on old business cards. And so he had just had a stack of old business cards that he made this activity with, and he had his students match them up. And so we actually got to do this inside the workshop. And John remembered his name, which is awesome. So he put that in the window for us. So what's kind of cool about this is I went back to campus and I typed them out and made them on 3x5 cards so that I wouldn't have to keep writing them out over and over again. And so like you can see this guy here in the middle, he's equal to x to the fifth, as well as I planted these when I took this picture. So these guys are equal to x to the fifth. So you would put them in a pile with this underneath this particular heading. And so this particular activity I used in an elementary algebra class, and it went pretty well. The negative exponents mixed in there, all the different kinds of expressions were really helpful for them to talk about and to kind of digest and to sort out. Now with this particular activity, I made it so that every category has the same number of cards, so that it was easy for me to check in class to see if they got to the same thing. And I also made some that didn't fit any of those heading categories, and that had the same number in as well. And I will be sharing all these things with you at the end of the presentation, so you can actually see the actual questions that I asked. And if you want to print them out and to make them for yourself, for your classes, you're more than welcome to do so. So this worked so well in elementary algebra that I was thinking about calculus. And I said, why couldn't I do the same exact thing with something like limits? So these look very similar to each other, and I've used this example before, so if you've seen them, you know that these look very similar to each other. And this creates, again, really, really good conversation inside my calc classroom. And it takes a while for them to kind of sort of, but once they get the hang of it, they really do catch on. And this activity is a little bit different because I don't make it so that they all are the same amount in each category. And I did make a set that was kind of big. I think I printed them on 5x8 index cards. I had them laminated, and I do tape them up on the whiteboard like I'm showing you right here in my class after they've been working on them for a while. So like, yeah, I'll go to each group, and they think it's hilarious. You go to each group and you look through their pile, and I just start tossing ones out, that don't, I'm like, no, reject it, put it back on the desk, because this is not in the right pile. And so then eventually I do release the answers. So just pointing out again that, there's some missing down here. They're not all the same length there. And then their whammies are off to the side here on the right, and they are not the same number of those either. And some of them, they try so hard the entire activity to try to make those two whammies fit into one of the categories that it really isn't funny. Students do need, for this activity, they do need some paper and pencil. With the algebra one, not so much. They can do most of those in their head or kind of talk it through. But with this one, I found that students do need to write a few things down, especially when they get a little bit more complicated. Another technique that I use in class, I call it pass and complete, really for lack of a better name. And so basically what you do is you start with different problems, and that's why I've got the different colored pieces of paper here on the desk. And they each have a different problem on them, and the student will do one line of the problem, like one step, and then they'll pass it to the next student. So when you get the paper the second time, the next student gets it, they will check the step above and then add their own. So I've been doing this in algebra class for a while, like elementary algebra, intermediate algebra, but this year I tried it with Calculus 1, and I said, let's do it with derivatives and see what happens. And the conversations, again, were really, really good. Let me show you a closer up view of one of these actual worksheets. So this was an actual problem that I had them do. I just called it pass and complete. You can see that I have derivative rules too. So I actually did this one twice, this kind of activity in my class this semester. So the handwriting is different, so you can tell, like this one student did the first line, then, somebody came along and did the second line. They kept simplifying until they got down to that final answer. One of the things that the students brought up, and it was more than I thought they were going to, is the how do you do this? Instead of taking a recipe for a problem and kind of following that algorithm, they were, why did you do it like this? And, could I do it like this? And having all that kind of conversation in there to really add to the conversation. So I don't think that anyone actually distributed the fourth power with this one, because I actually looked at them all, but it was just amazing to hear their conversation. Another thing that I do in class is I call it I'll tell you what to write. So I have my students in pairs, and they have one whiteboard, and this whiteboard is actually pretty large. It's one of those shower boards just cut down, and I want to say it's like 18 by 24-ish, but I can double check that. It's nice and kind of big, and it promotes students to write big, and I give them those big chunky markers so that I can see it from across the room, and I can really see what they're writing. So the person who has the marker has to listen to the person who does not have the marker to tell them what they're going to write down for the problem. And one of the reasons why I like to do a problem like this, I know it's upside down and kind of twisted here from my college algebra class, but it is because sometimes they'll want to distribute the power and sometimes they'll want to simplify what's inside that parenthesis first. So this particular pair of students, and they were working together again today. I took this picture this semester. They work very well together and have figured this whole activity out. You can imagine if you're the person who's writing and the person who's telling you what to write is telling you the wrong thing. Of course, conversation is going to erupt, and that is one of the cool things about that activity that I really like. Another thing that I do, another example I wanted to show you was from Trig. It's that same I'll tell you what to write activity. And when I did this problem to prepare for class, so my trig class is one of my hybrid classes, so we're practicing, this is from the chapter where you're like looking at the identities and the proofs and all that kind of stuff where it kind of bogs everything down. And in my math brain, I'm on the right side or the left side here all the way, right? That I would factor out a sign of A and to simplify that trig expression. But until I did this activity in class on these big whiteboards, I didn't notice that students were going about it this way, where they were replacing cosine squared with 1 minus sine squared of A and then simplifying from there. And it didn't matter, right? It's going to work out the same way. It all comes out the same. At the end of the day. But it was just kind of cool to see their different ways to do it. I do proofs this way in Trig as well because it really lends itself to the same thing. You know, there's more than one way that you could do a proof, so it's going to really kind of flush that out, and it creates, like I said again, really, really good conversation. Okay, the next kind of area that I wanted to talk about is connect and extend. And my example is going to be from calculus, just because this is a hot topic issue that we've dealt with at our college. And it has to do with curve sketching. And, you know, if I think back to when I learned curve sketching, and I joke around with my students that I was chiseling the answers in the cave wall, you know, because it was that long ago. But it was definitely before graphing calculators. So always a question that comes up, you know, kind of when we're talking about this as a department at OCC is, do you give them a calculator and have them do curve sketching, or do you take it away and, you know, have it, you know, emulate like, you know, back in the day when we were using all this information to try to find what that particular function looked like. So I have tended to stay toward the technology and to actually use it and to ask a little bit different kind of question. So it's not that I wouldn't ask my students to do the whole process of a curve sketch, but instead I also like to add in this next little layer of questions. And so I found this again online, the Infinite Looper, and I did contact him just to kind of ask him what he thought about me using this for today, and he was fine with it. And it was interesting because of the way that I'm going to show you how I use it. So I'll give this to my students, and this one I actually did in class today. And of course, you know, they're thinking, hey, these are familiar functions, right? I can see that I probably have an x squared, an x to the third, and then by default, that last little thin dotted one, it's very thin, this guy right here, is an x to the fourth. So they probably could figure out who is f prime, and who is f double prime right out of that gate. But it's a great first problem to start with. And so I don't always get to finish everything in class. And so the Infinite Looper has got a YouTube channel, and he has got all of his answers or solutions to these problems online. So I give them the QR code so that if they aren't at home and they're on their phone, they can actually just scan it and they can look at their answer while they're, you know, waiting for the next class or whatever it is until they actually could get home and get to a computer. So it's kind of cool that he thought it was kind of cool anyway, the Infinite Looper, that I was using his videos this way and his materials to kind of take it to the next level with my class. And if I couldn't explain everything, you know, to my small groups or my large group, that they still had an explanation when they went home. And then, of course, I kick it up a notch. So I'm going to give them a function that is not something familiar, right? This one is definitely not familiar. And like I said, I went through this whole thing in class today, so it was perfect for this webinar because they were like, you want me to what? Okay, now I don't have a familiar, you know, x squared, x to the third, you know, some kind of polynomial to hang on to. So what am I going to have to do? I really have to get to the heart of, do I know what it means when the, you the derivative is 0, what does that mean for the original function when the derivative is positive, etc. So that one's kind of kicked up a notch there, and I'll share that exact function and an example with you. This is a decimals graph, and that'll be linked to in my materials as well at the end. Okay, I was just catching up. Trying to read and talk at the same time is not always an easy feat here. So that's going to bring me to review, and you might notice that some of these things overlap. I tried to make it clean and tried to make it so that it had 4 disjoint topics, but we really pretty much don't, because things do kind of lean into each other as you try to break these topics up. So review. I wanted to throw a couple things out there for things that I do that might be a little bit different for reviewing. And here is a worksheet. It's my first one that I'm showing you here today. And so this is my Calc 2 class. Math 1740 is our Calculus 2. And our sequence, we're a semester-based school, so our sequence pretty much looks like Calc 1 is derivatives, and we do introduce integration, but we don't have all the techniques of integration in that class. That's mostly what Calc 2 would be. And then Calc 3 would be like when you get to the 3D stuff, okay? So picture here I am in a Calc 2 class, and this is usually the second day of class. So the first day of class, we have, reviewed a little bit. We talked about, hey, do you remember that you really should know the, for example, the derivative of arcsine, the derivative of arctangent, etc. And in this particular section, we have some, all this kind of review and kind of taking it again to the next level with the A's and the U's. My particular book that we use has the, like for this integral right here, it would be 1 divided by the square root of a 1 minus x squared first. And then in Calc 2, we take it to this level where we say, hey, we're going to make it so that we could have any function of x and any constant. Okay, and so at the bottom of the page is the cool part of this activity. So I've got 3 columns. I've got a column for integral. I'm going to say, do you know how to integrate it or not? And if you can you identify it? So I'm not going to actually ask them to figure out the problem, just can you identify it? Do you know what it is? And this is going to look strikingly familiar if you looked at my limit sort cards or anything like that. They all look so close to each other, right? So basically, this is kind of a roadmap that says, hey, during this class, we have got to be able to figure these 10 problems out. And you might not be able to do them all right now, but you can do some. Like, substitution, you might be able to recognize when you have an arcsine or arctangent, etc. But the rest of them, they just kind of have to say, yeah, we can't really do those right now. So that's what I'm talking about when I say my things kind of overlap a little bit, because there is a little bit of motivation there, right? There is a little bit to say, hey, we want to go on a little bit more so that we can actually do some of these other techniques in Calc. So it's nice to lay that foundation and kind of review what you already know, kind of analyze it, and then to go ahead and to move on. Another thing that I do in Calc 2 with all of these integration techniques is I have them write their own examples. So this chapter in our book is the beginning is kind of, hey, remember that you know how to do all this integration in the first section, and then they start to get into integration by parts, partial fractions, etc., those different techniques. And so I have them come up with their own problems. So like I have goofy names for them, like breaking up is hard to do is when you would break apart the numerator of your fraction, like this particular student did here with this one, where they actually split this guy up in the numerator. And I have that's just one of the cute names that I have for them. I'm going to give them all to you again at the end. But it's kind of nice that they can say, hey, I can go and grab that. And I did say you go ahead and use it from the book or from a previous test. You don't have to make it up totally by yourself. And so the other group their problem that they were assigned was divide and conquer, and they actually cited where it was in the book so that other students could find it, which was kind of cool. So when I have the students do this activity in Calc 2, I give each group a different kind of integration problem, and give them a few minutes to come up with an example, and then they actually present the problems. So they bring them up and just put them on the document camera and say, hey, this was the kind of problem that Mrs. Gunkelman wanted us to do, and here's how we worked it out, and here's my good example of it. Okay. All right. So I feel like I'm talking really fast, and it's because I can't see you guys. Let's see. Another thing that I'll do for review, so this looks very similar to that first activity that I had done with the, can I integrate it at this point or not? And I do ask it again, and the problems are actually the same. So I bring it up again at the end of when you've learned all these techniques, at the end of that section 8.5, and I see, hey, can we figure that out now? Can we recognize more of those forms? Okay, I have got a question for you, and it's going to help me hopefully segue into my next area, which is the motivate section, and it is, what is the hardest topic that it is to teach in Calc 2? The hardest topic to teach in Calc 2, and I'm hoping that you guys have some good answers for me. Oh, yeah. You guys are awesome because you're coming up with these great answers that I was hoping that you would say. So infinite series, trig substitution, I'm hearing series, convergence, and divergence. So definitely I think sequences and series is certainly a hard topic to teach in Calc 2. So that's what I was really hoping that you guys would say. So I want to tell you what I've done about that, because that has just been a horrible thing, I think. One of the things that I do to motivate students, it is exactly that with this Calc 2 question, is sequences and series, it seems so long before you get to the big aha that they've lost focus of what that big aha might have actually been in the first place. So I tell them, think about what we've done so far this semester. We have talked about integration. And we have, learned lots of techniques for integration. We've been able to integrate a lot of things, but can we integrate this guy? Can we integrate the integral of sines of x squared dx? Is that possible? Can we figure that out? And they'll sit there and kind of think for a second, and they want to make it sine of 2x, or like they're happy with that. They would want to make it that it's sine of x quantity squared, and they would even maybe come up with some the trig identity there to figure that guy out. But they're like, no, we can't do this. So ever since I started taking the approach that this is going to help us, whatever we do with the sequences and series, all these tests for convergence and divergence and all that stuff, really at the end of the day, it's so you can integrate this guy. And it made a big difference with my class to get them to get to that point where, yeah, even though it takes a really long time and I have a lot of skills that I have to learn to get to that point, it does make sense when they finally get there. They are a little let down because the crescendo takes so long. I'll admit it. Think about it. It's probably like three and a half weeks before you actually get to that big crescendo where you can actually integrate this guy. That they are a little bit let down. They're a little bit disappointed. They think it's going to be bigger than it actually is. I would be remiss if I did not mention the king of motivation, Dan Meyer. And the example that I picked is something that I use in my math for elementary school teachers class. So obviously this is a little bit different than some of the calculus examples that I've used here this afternoon. But Dan is famous for his three-act math. And so if you've never seen this before, this is hopefully it's going to be awesome for you. If you have, bear with me. So Dan's first act in his three-act math sequence for basically finding these perplexing questions is he wants to set up a situation for you. Now the one that I chose today does not need audio, although there might be a little bit of like wrinkling of the paper in the background if the audio actually does come through, but I chose it so that we wouldn't have a problem. Some of his have got, it's a picture that would inspire a perplexing question, or maybe it's a video that shows something is happening, demonstrates something, and to ask a perplexing question. So this one is called Popcorn Picker, and I'll show it to you. Okay, so I will show this student this video in class, and then I'll ask them for what kind of question you might have, or why I might show this to you. Eventually, they will come up with the right answer, and it is what container holds the most popcorn. And so try not to be a math major right now. I want you to answer this question. Is it the one that's going to be on the left, the right, or are they the same? And John's got the same questions up on the poll for you guys to fill in. And I don't want you to think long, and I don't want you to grab your calculator, just to go ahead and to answer that. Oh, I might have to vote so I can see, maybe. Oh, there we go. Oh. So you guys are playing students so well. I really appreciate it. So it looks like about 40% of you are saying the container on the left. There's about 10%, 11% saying the container on the right. Now the numbers are moving. And about 50% hold the same amount. So again, I did this with a math for elementary school teachers class for the first time. And I never expected that they would pick C. I was so naive. I'm like, what do you mean they're going to pick C? And in fact, I didn't even present that as a choice the first time that I did this in class, because I wasn't even thinking about the fact that, hey, they could really hold that same, they could actually think that it would hold that same amount of popcorn. And so then everyone voted for that because I hadn't put it up and they thought I was trying to trick them. It was pretty interesting. Oops, I bumped something there. So the next thing that you want to know if you're actually going to try to solve this problem is what information do you possibly need to figure out the volume of each container. And Dan calls this Act 2. So he's going to get to the point where instead of like in a textbook where you've got your certain information that's all given to you and you're just trying to pick it all out, it's a little bit deeper of a question because we're saying, hey, what is it that you really need? What is it that you would like to know? What do you need to know so that you can actually answer this question? And so his Act 2 is always a reveal of this type of thing. So this one I think is just a picture. There's not a video that actually goes with it, and he just says, hey, this is just a normal 8.5 by 11 sheet of paper, and in one case I have it turned so that it's like a landscape, and the other one it is a portrait. When I've actually repeated the demonstration in class, I have used different color pieces of paper so that we're not like saying left and right. So I've actually made the tubes in class and demonstrate it live because I sometimes think they think that I'm like have trickery going on with the camera, or Dan has put something up there that isn't quite right. So it takes a little bit of conversation, even with math for elementary school teachers, to get to the point where you've got the geometry, to figure out what it is that is actually going on when you wrap that piece of paper around, and that the circumference is actually the other edge, not a radius like you want it to be, or a diameter so that you could do an easy calculation. So that, of course, in the back of the book, like he says, we just watched the video to get the answer. So here is Dan's Act 3 of this particular perplexing problem. So the answer, I was just looking at the chat window. I thought something kind of funny happened there, but it seems like I'm back. So that's good. So the answer is, Dan has got a bigger pile of popcorn here on the left, and you can actually see the answer. It makes it a little bit more tangible than just saying, hey, this is the answer, this is what you should have gotten. You can actually see it. And again, the look on students' faces when you do this in class is phenomenal. I've also seen it done with rice. So instead of popping popcorn, I've seen it done with rice. So you could try that as well. I don't know, it kind of makes a mess no matter what I pick. And rice seems harder to pick up off the carpet than the popcorn. Okay. Now if somebody wants to eat popcorn, that's what my students always say as well, is that they definitely want to eat some of that popcorn. I have got, that was my last example, because like I said, Dan is the king of motivating topics. But I did want to let you know that I do have all my materials posted in a live binder, and I'd like to just kind of give you a little bit of a tour of that before we take the questions here at the end. And so this link, this QR code, will be shared with you again, so it's okay that it's going to go away here in a second. Let me just switch over. So the link is going to take you to a live binder, and a live binder is just a free kind of like online kind of storage place. Instead of putting something in a Google Doc for you today, I just organize it into this live binder. That the title is there. I put the tabs along the top of the screen in order. So the practice, the connect, extend, the review, the motivate, so that they would be in the same order that I did in the presentation. So if you wanted to see, for example, this is an overview of the practice, kind of describing what those things are. And then when you actually go ahead and hit on, for example, the hexagon puzzle, you're going to get right to Susan's page that she has online. I don't want to make you dizzy, but you can arrow down and you can actually see the puzzle. My exponent cards that I used for algebra, again, elementary algebra class, they are posted there, and again, you're welcome to use them. If you print the file out on a 3x5 index card, it works pretty well. The limit sort cards are there as well from Calculus 1. Again, that was the one that I did to have my students sort out those limits. I put the pictures of pass and complete, so the derivative rules that I did with my students this semester, I put that in there just so that you would remember what that means. I tell you what to write, I think I've got that picture in there of my students, and no, I didn't put the trig one underneath. The connect and extend, all the stuff from the Infinite Looper, he puts all of his worksheets online. They're usually in the description of the video. So this is the one for curve sketching. And then all of these tabs that you have here that say like curve sketching 1, that's going to be the video that he made that links to that example 1. So if you wanted to check that out, you could. At the end of this particular tab set, I have the who is who, which is the derivative activity that I did when I made it a little bit harder. Go ahead and put that in projector mode. So that was this crazy graph that I used in my class today to ask them, which was F, which was F prime, which was F double prime. So if you've never used Desmos, this is kind of cool. You can share all of these Desmos graphs with your students as well. You can get a link to do this. That's how I put it inside the slide binder. And what you might want to notice is on the left-hand side that I've got the function, and then I've got, like, when it says 2 here on the blue, this guy where I just highlighted and put my cursor, that you can actually put in ddx of f of x and it'll figure out the derivative for you. I put another one in there because I thought this one was kind of cool. If you wanted to check it out, just kind of the crazy functions that I give my students to try to figure out who is f, who is f prime, who is f double prime. So that's all in there. If you're curious to see what I did for review, I do have the Write Your Own. That was the activity that I did with Calc 2 when I had them do the different topics, and also the Who's Who when I give that review, and you can see those problems so you don't have to go to the actual slide. Underneath the Motivate section, I've got the actual one that I did today with Dan Meyer, the popcorn picker. I use quite a few of his algebra classes, a lot in math for elementary school teachers. Not so much in like college algebra or trig, but in the ones before that class. I linked right to his blog so that you can read kind of what's going on with Dan. And then this is the most cool thing ever. I wonder how many people are on here. I can't quite see, but this is a Google Doc that has got a list of all of Dan's activities, and mine's not showing because my window's too small. But usually, every time I click on this, there are 20, 30 people all looking at this document at the same time. It's pretty cool. Contact information is in this last tab here. That was the same stuff that was on at the beginning. And then I did put all of the slides for my presentation in this last tab in case you wanted to see something, review it, etc. Along the way there. So I think that brings us to the question part. I don't know if you want me to stop sharing, John, or if I should just leave it.
Well, why don't you go back to your contact information, and then
Okay.
if he wants to write that down, maybe you can bring up the link to the live binder again in case somebody wants to write that down also.
Okay.
Or
All right.
can you put them on the screen both at the same time, maybe?
Sure. Sure,
And
sure,
then
maybe.
if
Maybe
there are
not.
any questions, we can leave your screen share up for a few minutes in case somebody wants
Sure.
to go back to a specific item before
Okay.
we wrap it up here.
Okay.
So I'll leave you for a second to take a few questions. So if you have any for Julie, just put them in the chat room.
I appreciate the thank yous. Just kind of waiting to see if we have any question. Anna, I would love to spend a day with you. You can come anytime. We're from the same state. If any of you guys are visiting Michigan, you guys could come hang out with me too. That would be awesome. Just waiting to see if there's any questions. So one of the questions is when you do this, you say what I write, how do you handle it when students don't want to write what others are saying, they disagree? I kind of let it go. I'm not going to like force somebody to write down the wrong thing, but like I said, the conversation erupts and it's a natural way for them to get to talk to each other. I tend to do this activity first at the beginning of the semester when people don't know each other as well, and it really does kind of help break that barrier, and they eventually get into the good questions like, well, why would you think I should do it that way? Or, you know, have a conversation about how it maybe should go instead. Another question is, how do you keep students on track, especially when you do the one line and pass it on? That one was challenging, and I I have my calc class broken up so they're in 6 different groups, 6 small groups. And so that's enough groups that I can keep busy and give them time to think while I go around to each group. But I would ask them questions like, much like you would do if you were just sitting down with a student one-on-one. Why did you do this? Do you really want to do that? Can we maybe try something else instead? And sometimes they would, and I don't think I scanned any of those to share with you, but sometimes they would start over and they would say, okay, I think we derailed this problem. Let's start over. And it was good because then they could find out why. And so it's not like when you're alone in your home at 10 o'clock at night and you're like, I can't really figure out this problem. You had that cohort, that group of students to actually work with to work through it. Okay, just trying to see what else is coming in here. So one of the questions was, do you use these activities primarily for hybrid classes? That's kind of how I started. So if you back up to my journey on this, I started the hybrid classes first. And when I first started my hybrid classes, I did not have a good sense of what is it that I do in class and what should I not do in class. Like how am I going to use that time the best? Because I was like, oh my gosh, maybe I do need to do a few of these examples live. And what ended up happening is that my students rebelled. They wanted the video notes because I had trained them that this is how we were going to do it. And they wanted the practice, the connect, extend, etc. They wanted that part in class. And so they let me know that fairly early on. So with the hybrids, putting all the content online was kind of a no-brainer. That was an easy distinction for me to say, okay, I've got 2 hours in class. I want to use it. And I don't want it to be introductory material. I want it to be a higher level. This is the first year that I started flipping the classes where I'm not doing any introductory material or much of it in class. So there is still, like, I might say, hey, this is what I want you to look for when we're doing the video notes tonight or for the next class, but I'm not doing it. It's the same kind of video. So when we are meeting with the flip classes, obviously I need more activities because I see them more often, and richer experiences. So that's been the challenge for me this academic year, is coming up with more of them so that I can maintain that flipped model where we are getting to a deeper level when we're meeting together, not introducing it for the first time. Okay. Oops, I missed some. So, trying to scroll. I think that's it. You're welcome. This was a great experience for me. I hope to hear from you guys, even after. If you shoot me an email or you tried something or you had an idea and you made something different or better from what I did, I would love to hear it. That would be awesome. You can connect with me on Twitter, email, etc.
I wasn't cutting you off, Julie,
Nope,
but I
that's
was trying
fine.
to find
That's
my
fine.
slides.
No, it
So,
was a perfect time to stop, I think. I don't think there are any other questions.
well, if there are any other questions, feel free to put them in the chat room now. But thank you again, Julie. And if anyone else wants to thank Julie again in the chat room, that would be great. So thanks again for participating in today's AMATIC webinar. And if you'd like to support future AMATIC webinars, please consider becoming a member of AMATIC at bit.ly/join-AMATIC. And please remember to like us on Facebook at facebook.com/amatic. And recording of past amatic webinars can be found at bit.ly/amatic-webinars. And it typically takes us 1 to 2 weeks to produce and upload webinars to this archive. And if you could please take 2 minutes to evaluate the webinar content and the presenter today at bit.ly/amatic32. That would be great. And you can click right on that link on your screen or type it in. And if you need email confirmation of your participation in this webinar, please fill in the optional section at the end of the evaluation. So I do think there was another question in the chat room, Julie, so if you want to address that real quickly, we do have time.
Did respond in writing. The question was, how do you handle those students who come unprepared, and do I take time to catch them up? And I said no, because if I start taking the time to catch them up, then they're going to expect that I'm going to do that all the time, and then I don't get that deeper that next layer of understanding I'm introducing. So they're kind of out of luck, which is bad, and their peers don't want to work with them. So that it doesn't happen that often. As soon as they figure out that you're not gonna go back and stop and collect them, they figure it out pretty fast that they're gonna watch that. I think I answered it.
Well, yes, and thank you again,
Okay.
Julie. I'm going to stop the recording now.
All right.